Before using any machine in the shop, you should read and understand the owner's manuals. Today we're going to be talking about our wood lathes, and this one is our full-size lathe. And the advantage of the full-size lathe is that it has a bigger spin over the bed, meaning we can turn a bigger diameter piece over the bed of the project or over the bed of the lathe. And it also does a longer piece or stick between there. If we're turning spindles, we could do table legs, things like that, where we couldn't do that on our other lathe. This is one of our mini lathes that we have in the shop, and the mini lathe is just like the full-size lathe. We can do a smaller turn over the bed, so we cannot do as large a diameter of projects, and the bed length is not as long, so we are unable to turn long pieces like table legs. But for all other turnings, this does pretty well for meeting our needs. So there's four main parts of the wood lathe you need to know about. There's the front part. This is called the headstock. The headstock is what drives the workpiece. There's a motor attached to some pulleys in here that transfer that through the center and make your workpiece turn. We have our tailstock. Our tailstock is on the back side of the machine, and that supports the back side of the project. We have our tool rest here, and this is where our tool rest rides against when we're cutting. And then we have our bed that kind of connects everything together. So the bed of the lathe, the headstock, the tailstock, and the tool rest. When we change out our centers, the front one here is held in with pressure. This has a mortise taper on it, and the mortise taper is held in just by a pressure fit. And so we need to use a knockout rod, which I have one on the table here. We're going to insert that into the back side of the headstock and feed it through there, and we're going to tap on the handle until it pops out. We want to make sure we hold the center so that it doesn't fall and hit the machine or fall and hit the floor. So we're going to hold on to it and tap on it with the rod, and it should come out pretty easy, and then you can change it out or pick the appropriate one that you want. The tailstock is a little bit different. It also is a mortise taper that's held in there, and so it's just a pressure fit. But the knockout rod you should not have to use through the back end. For the most part, you should be able to just unscrew this handle, and this backs all the way in. So we'll loosen the little clamping lock. We'll loosen the handle until this gets up close to the machine. And then once it goes all the way in, it pushes or drives that center out. So you just back that up and it will push it out. Now if for some reason that handle doesn't go in far enough, we can use a knockout rod through the back end, through the hole in here, to knock that center out of place. So the knockout rod would go in and you could tap on it just like the front, or you could back that support up until it pushes out the center. Now this center here would be considered a live center, and what we mean by live center is that it spins. So there's some bearings on there that spin, so as this is supporting the back of your workpiece, you're not burning the back edge of your workpiece. If this was a dead center, meaning that there was no bearings and it stayed in one position, your workpiece would sit here and pivot on this point, and this would get hot from friction and cause burning into your material. So when we're ready to put a new center into the tailstock here, we're going to extend this out of the housing a little bit, this support, so that we can actually not bottom out in there. And then we're just going to push this on, and a little tight pressure should hold it for now, and it should be secured in there. Here are some of our different varieties of chucks to hold on to our workpiece. We have our regular center here, and these would be the centers that fit into the headstock. Two different types. This one's got a whole bunch of little spurs on it. This one's got smaller, larger spurs and fewer of them. So those do the same thing. Again, you're going to drive those into the workpiece. We'll show you that in a minute. We also have a faceplate The face plate is going to be used to screw on to a workpiece. Usually this is one of the first steps when you're turning like a bowl or plate type project, is you would use the face plate and screw that onto your workpiece. And then we have a 4-jaw chuck like this here that would be more of a finishing process for a bowl or plate. You would start with your face plate and get that turned, and then you would create a little notch that this chuck could open up into and grab onto that workpiece. So the 4-jaw chuck is another one. And then we also have some other miscellaneous things, like this here uses these dowel screws that we could have a chunk or block of wood that screws into and turn on the wood lathe. And then this last one here, this is our mandrel. And the mandrel is what we use for turning our pens. This is the block of wood that we're going to install for today's demonstration. This is a piece of cherry. We're going to get where the center laid out on this block. And to do that, the easiest way to find center is going to be taking a straight edge and drawing a line corner to corner. Today I'm using a pen so it's a little bit more visible for you, but typically when writing on wood we want to use pencil because pen and marker will bleed down into the grains of the wood and be a little bit more difficult to sand off. You may also come up to a board that has a chipped corner or maybe a little slightly rounded corner, and the best way to handle that is to have a square chunk of wood. So our distance right and left is the same as up and down. Then we can take our speed square and just simply use the 45-degree angle portion of the speed square to find center. So we put it up there nice and tight, mark it. When you have center laid out, we're going to flip the board over and do the same thing to the other end. On larger diameter stock, we could take and cut some kerf lines into the workpiece using the bandsaw. Now we could use the bandsaw and tilt the table to an angle, or we could use a V-block to hold our workpiece at an angle so that that lines up with the blade. So if we take this and line it up with the blade, we can see that that V-block holds it nice and at the right angle there, and we'll make our cuts here. We'll show you what that would look like. We're going to put our workpiece in the V-block and turn the machine on. So we've only went in about 1/8 of an inch, not too much. This is going to allow us to not have to waste so much material. If we were to cut this groove way in further, then we would have to have a lot more waste on our good piece of material. Now that we have our kerf cuts in there, we're going to take our center, we're going to line that up to the center of our kerfs there and get those spurs lined up with the kerfs. And we're going to take a mallet, never a hammer, we don't want to use metal on metal, and we're going to take our mallet and tap that in, rotate it around, make sure it's in there nice and secure. Now if we take a look, we bring this closer, you can see those spurs are driven in there pretty far, so they should not work themselves loose. We can do this kerf cutting from corner to corner on small pieces, but on big pieces it is required. We should be doing that. Now let's go load this in the wood lathe. So now we're ready to load our workpiece. We're going to take our center and push it into the headstock, and a friction fit is what holds it in. Now we're going to line up our kerf marks and the spur marks that we've hammered in there and get this installed. Once everything lines up, I can hold it up here. It pushes in nice and tight. I can see my spurs are down in there where I drove them into place. Now we're going to go to the tailstock and get that put in. And take this point and line it up with my other X. So I'm going to loosen my handle on the back here. I'm going to move my tailstock forward and line that up right about in the center of the X. I'm going to lock down my handle on the back side. And then I'm going to tighten the handle back here to get this center to move out and towards our workpiece. So I'm going to tighten up that handle, and you're going to see it start to sink in here a little bit. As it's sinking in, it's also pushing this center back into the housing and the far center up into that housing a little bit more. If you're tightening this and you can actually see the base of the machine moving, maybe that needs to be tightened up a little bit more, and then you can tighten it. If it still moves, then maybe it's too tight and you don't need to be moving it anymore. Make sure it's tight and that your piece is secure in there, and we should be good. Once your piece is loaded in here and your back tailstock is tight, we can tighten this little locking lever here. This is going to help prevent the tailstock vibrating loose from our tool cutting our workpiece. This is going to create some vibration as it's spinning, and rather than transferring into here and vibrating loose, this will help keep it a little bit more tight. We're going to take a look at some of our cutting tools. Our cutting tools are called chisels. Now we have a few different profiles of chisels and or different shapes of chisels to use on the wood lathe. This one here is called a gouge. It's kind of U-shaped. It's got this radius cut in there. If I turn this around, maybe you can see it a little bit better. So it's got this U-shaped pattern. The tip is sometimes rounded like this. Sometimes it's left flat, depending on what the cutter has been sharpened to. This gouge is one that's going to be used as a rough cutter. It's going to remove a lot of material at once. Okay, gonna have big chips coming off as we use that one. Again, that's called the gouge. Here is another gouge, and this one has a little bit smaller radius in the profile cut there. It does the exact same thing as the big one. It's just smaller for maybe smaller work pieces or tighter areas that you're trying to get into. Next, we're going to have what's called a round nose, and that's simply just a flat kind of piece of metal with a rounded edge or nose on there. As we look at the flat edge here, you'll notice that the sharp edge is on the top side, and then there's a back cut on the back side to kind of get rid of those chips. So as it's cutting on the top surface, the chips don't get stuck between the cutter because there's that relief cut on the back side. The round nose, again, easy to identify because it's a nice rounded nose on the cutter. This one is called a skew. Now a skew is going to be a fine cutting tool. It's going to create a lot smaller chips. It's going to give you a smoother cut when you're done with it. The skew is easy identifiable because it usually is at an angle. The top edge is a skew or it's at an angle there. Okay, so it's not straight. This one is sharp on both sides. So as we look at it, there's not necessarily one side that goes up or down. It could be held either direction because both sides have a nice sharp point. The next tool here, this one is called a cornering chisel. You can kind of see it makes a 90-degree corner here. You could use this on projects when you're trying to create some inside corners. It's got this back cut on there again to kind of relieve the pressure so chips don't get stuck between the cutter and the workpiece. So that one is called the cornering chisel. And this last one we're going to look at for today is called a parting tool. So it kind of looks like a spear. It's kind of a sharp point. Okay, that would be used standing upwards like this, not flat. The other ones have all been laid flat so far. And this allows us to create deep grooves or channels into the workpiece very quickly, removing or parting away those materials. So these are the main tools that you would use when cutting. There are some specialty type tools that are available for the wood lathe, but in here these are the main 5 or 6 type of profiles or cutting chisels that you would see. So with this block of wood, now this piece isn't too big, but if this block of wood generally we say is larger than 3 inches square, so each side of the square is 3 inches or bigger, then we would want to cut the corners off to give it a more round shape. So since it's not, we don't have to today, but what I mean by that is we would take this to the bandsaw and tilt the table on the bandsaw, and we could come in and cut and kind of give it some extra sides here, and so that we're more of a circular shape once these corners are removed away. Before we start using the machine, we typically do our cutting at low speeds. And so we may need to go into the machine and adjust the speed. So the machine is variable speed, meaning that we have a range that we can turn up or down, and it's going to go faster or slower. But that range is limited by the belt speed based on the pulleys. If we open up these little guard doors here, we can see inside the machine, and as we take a look, you'll see a pulley in there. So we have a big pulley, a medium pulley, and a smaller pulley. That's for the driving the headstock. And down on the motor side, we also have a large pulley, a small pulley, and a medium pulley. So you're going to line those up based on the speed. And if we look right over here at the door, it gives us a chart. So if we have it over on the smallest pulley on the bottom, we're going to be at 50 to 520 RPM. If we are on the medium one, we could be in the 325 to 1700 RPM. And if we're on the biggest one, we could be at 650 to about 3500 RPM. Okay, so to change the belt speed, we want to make sure that the machine is unplugged, which it should be no lights on the display, and the power cord should be within your control. So I would move that either up by the machine, you could put it in your pocket, whatever you want to do. So the first thing we need to do is take the pressure off the motor. And we're going to use this little locking handle down here. We're going to lift that up, and it raises our motor up so the pressure is off of the belt. Again, machine needs to be unplugged before you put your hands in here. These are pinch points that could hit your fingers. So we're going to go to the medium-sized pulley for right now. And so I'm going to move my belt over. I may have to go all the way over to the side here so that I can get this upper one over to the bigger size. So now that I've got my pulley moved over on the bottom, I'm going to line it up on top, come back to the bottom, and get it on the middle pulley. Once I am on middle, on top, and bottom, and I make sure everything looks like it's nice and straight, then I can put the pressure back on the motor so that the belt tension is tight. When we're done working in here, we want to close the guard doors so that they are not exposing the belts. All right, we're going to talk about setting the tool rest. Now the tool rest, typically when we set that, should be at or just slightly below center of the workpiece. So we can use this center here as the center of the machine or center of the workpiece. It should all be the same. And we're going to actually have our tool rest today slightly lower. And because our tool is going to sit on top of there, and so the cutting edge of my tool should be right about center. Now the correct distance away, we should have the tool rest about 1/8 to 1/4 of an inch away from the workpiece. So we're going to loosen the handle here and slide that back. Now we have a unique situation that right now we have these flat edges and the corners. So if we set it 1/8 to 1/4 on the flat edges, then when we spin it, it's going to hit the table, or it's going to hit the tool rest. So we need to set it about 1/8 to 1/4 of an inch away from the corner pieces. Now this is going to give us a little bit of a gap while we're turning that we're going to have to try to manage the best as possible. So I'm going to get it about 1/8 to 1/4 of an inch, and then I'm going to use the locking handle to lock that in place. And then once you've locked it in place, we want to turn the workpiece by hand and make sure we're not hitting the tool rest. We'd never want that to hit the tool rest when we're working, because that could cause it to come off and hit us in the face. So one unique situation we have here is with that distance, because of the corners, we have a large gap between the fence and the workpiece, or between the tool rest and the workpiece. And so as we're cutting, that large gap could potentially cause our tool to come in closer and get stuck as we're turning. Okay, if that were to happen, you can turn the machine off. Sometimes you can just gently pull back, and that's enough to cause it to free up. But because that gap is so great, we have a chance of our tool getting stuck between the tool rest and the corners. So once we're ready, we spin the workpiece by hand, make sure our corners are not hitting the tool rest. Okay, we should only be touching the workpiece while the machine is turned off. If the machine is turned on and running, we should never touch the moving workpiece. They could get splinters in our hands. Our finger could potentially get caught between the tool rest and the workpiece. So don't ever touch the workpiece while it is moving. Like our other machines, it is the operator's responsibility to check the cords, make sure the prongs are all there that need to be, that the cord is in good condition, no abrasions or breaks in the outer protective layer, and make sure it's good all the way back to where it goes into the machine. If it looks good, then we're good to go ahead and plug that in. Once we've plugged that in, we want to make sure the cord is free of the machine, that it doesn't potentially get stuck or caught in the spinning rotation of the machine. Now with the power applied, we have a display over here that indicates how fast our rotation is. So before we turn this on, we're going to turn it all the way down to 0, or the negative number here. We're turning it down to a low speed. We have our on-off switch, and we have forward and reverse. You may use the forward and reverse if you're sanding. Maybe you want it to spin the other direction so it's not blowing the dust in your face. Maybe there's some other applications where you would use forward and reverse. But for the most part, we're going to be working in the forward setting. So we're going to go ahead and turn the machine on with the green button. It's not spinning or rotating, and that's because we've turned it all the way down. So I'm going to turn it up just slightly until we start rotating here. Okay, and remember, we're just barely at the cutoff there. We're turning our workpiece at low speeds. We're going to do our sanding and finishing at high speeds. Now in the camera it may look like it's spinning the other direction, but it actually is spinning towards us. We need the workpiece to spin towards us so that as our tool is here, it's cutting. If it were spinning away from us, it would just want to lift the tool off the workpiece. So it does need to be rotating towards you on the top side of the board. It should be rotating down on that side. So we're going to get it turned on to a reasonable speed. Until our corners are gone, we're going to be going slower. I would say until those corners are gone, maybe under 500 RPMs, or revolutions per minute. So that's got a pretty good spin to it right now. And so now that we've got that ready, we need to choose our correct tool. So we're going to shut the machine off. Anytime that we're not actively cutting or setting up, we're going to turn it off. I'm going to start with my round nose. So we have our tool that we chose. Now there's two hand positions that you could use. One is kind of an underhand grip, and your index finger here is going to ride along the tool rest. So this forward indexing finger here is holding the workpiece and preventing you from pushing in too much. It kind of gives a nice riding effect on that tool rest. Okay. The other way is going to be an overhand grip, and this part of your hand is riding on that tool rest. So as I get over here and look, my hand would be riding right along that tool rest. Either hand position, it doesn't matter. Your hand needs to be touching that workpiece or the tool rest. If your hand is way back here, you don't have enough control. It can vibrate around and move more. So your hand is right up here holding the tool on the edge of the tool rest. Your other hand should be at the back of the handle, and you're holding on to that nice and secure, and you want to keep it near your body. The further out you go, the more leverage the tool has on you, and it's able to move around a little bit more. So you want that nice and close to your body. Now as we're cutting, you may find that maybe your tool is getting dull in one spot or another. So maybe you want to use a different edge. So you've got this whole radius here that you could use. And so as you're cutting, maybe you want to move your whole body over, and now we could cut on this part of the tool rather than right on the tip. Or maybe you move this direction, and now you're cutting with this part of the cutter, right here on this side of the radius. So you can always adjust your tool. You could try from side to side. Maybe you feel like you're not getting a good cut and you raise the handle up or lower the handle down just to try to get a better cut angle while you're running the machine. When we first turn this machine on, the piece is going to start rotating. We're going to get all ready, and we're going to just very gently bring our tool up against here. So as it's spinning, we're just lightly engaging the tool to the workpiece. We don't want to jam it in there. We don't want to get stuck between those corners. So we're going to just very gently bring it up to there and do your cutting. Now once this gets round and we're going to move our tool rest closer, then it becomes a little easier not to get stuck in here when your workpiece is a little bit more round. Let's turn it on and give it a try. So we've got our speed already set. Turn it on. I'm going to pick my whatever direction you want to hold that, and we're just going to very gently or lightly bring it in, and it's going to start cutting. Now as this is spinning, if we look at the back horizon here, we can see where we've cut and where it's low and where it's high. So that's one way when you're cutting. If you don't want to stop all the time and take a look, you can look at that back horizon when you're cutting. I also like to cut from the center of the workpiece towards the outside. So I would go center over to the left and center over to the right. I feel like when I start right on the edge, it tends to chip off more and your pieces get cracked a little bit deeper in than you would starting from the middle. So we're going to turn on this until we get it round. Our tool always needs to be touching the tool rest, so don't take it beyond the edges of the tool rest. You can see it got stuck in there. For the interest of time, we will occasionally speed up the video. All right, we're going to stop and take a look. Now when you're cutting, sometimes what will happen is these large chunks may be coming off and flying at you. So these big chunks, as they're coming off, may be flying towards you. If you are having these hit your face, you could wear a face shield in addition to your safety glasses, if that's something you want to do, if you've got these large chunks hitting you. So as we're turning, we're cutting away these corners, and now we're creating a bigger gap in here. So now that my corners are starting to come off, I'm going to need to adjust my tool rest to keep that 1/4 to 1/8 of an inch gap. Every time you adjust the tool rest, we want to spin it by hand first to make sure that we are not hitting. And then you can start it back up and keep turning. So we're starting to get round. We can see down here, we're starting to get all the flat spots off. The flat spot starts about here. We don't want to keep turning this part because it's already starting to get round. We want to come down here and get the whole thing round before we start doing anything. When it's still square down here, there could be a slight vibration or offset that would cause this to kind of not be symmetrical. And so we want to get this whole thing round before we do any of our profile or cuts into it. So let's move the tool rest back down to this side. We're going to get as close as possible without hitting, and then lock that in place. So you've seen a couple times where my tool has gotten stuck on those flat spots. The closer we can keep the tool rest, the less likely we are to get those tools getting caught in there. Again, we want to maintain about 1/8 to 1/4 of an inch away from the workpiece. So we moved it, we're going to make sure it's not hitting, and then we can go cut it again. So let's stop and take a look. A couple things we need to do when we are ever checking the workpiece or moving the tool rest, we need the machine to be turned off so nothing gets caught up in the rotation of the workpiece. Also, we want to check the back tailstock occasionally. We're going to loosen this locking mechanism on top and then tighten up the handle just to make sure it hasn't vibrated loose on us. So every, I don't know, 2-3 minutes, stop and make sure that that tailstock is still nice and tight, that your workpiece doesn't run the risk of flying off and hitting you in the face. We can still see one little flat spot right in here along the workpiece, so we're not quite there. My tool rest is right at the edge of that, so in order to continue to get that, we're going to need to move the tool rest down to the other side. So again, as this is spinning, if we take a look at this back horizon where the workpiece starts to curve, we can see where our high and low spots are. So we've got a little bit of a low spot right in here and a little bit of a low spot right in here. If you are laying this out for something, you could take your writing utensil and measure and put marks on your workpiece where you want certain things to be laid out. That works. Also, an outside caliper could be used in laying out your stuff. You could set this to the size of diameter you want to finish at, and you can run that along the surface to see where you're at. Or maybe you have multiple pieces. You want everything to be the size of that. Or maybe you have one little bead. You know that all the little beads need to be real small. So you can use this to verify your settings or sizes. Now, you don't want to use this while the machine is running. This would be used while the machine is turned off to check your sizes. So we're going to go ahead and cut some different shapes in. I'm going to grab the gouge and show you some work with the gouge. Again, looking at that back horizon, we can see the shapes that have been cut in there. So when talking about our cuts, we have our coves that sink in like this, and our beads would be like this high spot here where it kind of beads up on the top edge. And then our flat cuts would be what we did previously down here. Now, as we look closer at this workpiece, you might notice that there's quite a bit of a rough edge right here. And the reason for that is that we have been cutting with the grain. This is with the grain here. And when we come down and curve in, we now are exposing end grain. The same type of end grain that we would see down here on the end of the project. And so that end grain typically is a rougher material, and that's where we're getting all this rough tear out, is because that is end grain that we are exposing. That tear out's fine. We would just want to leave it a little bit bigger or thicker than we need. That will allow us to come in with sandpaper and sand it all nice and smooth. So we're going to give the skew a try. Remember, the skew is at an angle. It's sharp on both sides, so it doesn't matter which orientation you hold it against the tool rest. It could be that way or that way, and you could even use it up and down a little bit to get yourself some little grooves or notches cut in there. But most of the time we keep it flat. We should get a lot smoother cut this time. We can maybe hit this end grain a little bit and see if we can clean that up. Now, these sawdust shavings up here are creating friction as they fall off and as they hit my finger. So if it's a little warm, just brush off those sawdust chips. If the metal chisel is actually hot, that means it's dull and needs to be sharpened. Let's take a look here. This is the section that I just used the skew on, and this is the section where we use the gouge and round nose, which is a lot rougher. So you can see how that skew is giving us a much more finished cut than the rougher cutting tools. When you've got the profile or the look that you want on your workpiece, we can start sanding. So when we're ready to start sanding, we need to change the speed of the machine so that we're using the highest speed to make the sanding a little quicker. So we're going to unplug the machine and readjust the pulleys to get the right setting where we need that to be. So unplug it. Once it's unplugged, we can access the pulleys through these access doors here. So we're going to adjust the pulleys for our speed setting, and we're going to do that by taking the pressure off the motor with this lever here. It raises the motor up so the tension is off the belt. So I have moved the pulleys, or the belt on the pulley, I have moved from the bigger pulley here, or the medium-sized pulley, over to the small pulley, and then down below I've done the same thing. I have moved from the medium pulley over to the biggest pulley, and so this should make us on our fastest speed here according to the door chart. So once I have my pulleys and the belt is straight up and down on both of the corresponding pulleys, I'm going to take the pressure back off the motor and put the tension back on the belt. So now we should be on our highest speed range. All right, so we have our belt changed to the higher speed. We're going to close the guard doors, plug the machine back in, and we should have power to our control unit. Now we have this variable speed that we can turn all the way up for our sanding. Before we turn it on though, we need to move the tool rest out of the way. We don't want to have any chance that our fingers could get caught anywhere in between here when we're sanding. So this would be a pinch point or a hazard. We need to remove the tool rest by simply loosening it and sliding it out of the way. Another good thing to do at this time is to make sure that the tailstock is tight. I'm going to loosen this little locking lever and just make sure the pressure is still on the tailstock end so that this doesn't fly off and hit me. So now that we have this set up, we need to talk about holding our sandpaper, and we have a couple options. So we're going to hold our sandpaper either on top like this with two hands and kind of loosely holding on, so if it were to get caught or grabbed, we can let go easily. The other option for holding a sandpaper would be kind of underneath like this, and usually that's only a one-hand operation, but that is going to have a lot of heat build up on your hand. Now this is the kind of sanding we're going to do, especially in these radiuses. We're going to take our sandpaper and kind of curve it into a profile or radius there that would fit in sand into those radius or tight corners easily. We're going to turn the machine on and let it get to full speed.
And now start our sanding.
So when you're stopping to check your workpiece, we should always be turning the machine off. Don't ever touch the workpiece with your bare hand while it's spinning. We could get slivers or splinters. Now as we look here, we have some tear out that's still there and pretty deep. The majority of our workpiece looks pretty smooth, but we do have that tear out there. Another thing we're doing is we're creating what's called cross grain. We're scratching against the grain of this workpiece as we're sanding so that these little lines or grooves are cut in there. So we're going to have to make sure we take extra time to get rid of that cross grain or scratches against the grain that we're creating because this is rotating and we're sanding against it. So we're going to do a little bit more sanding. We're not going to sand this up nice and pretty like you're going to do on your workpieces because this is just a demonstration piece that I'm showing you. But we'll do a little bit more sanding. When you do your sanding, you want to make sure that you don't skip the grits. if you skip from this 80 grit right up to 180, these scratches are going to take a lot longer to get out. You want to follow the typical sanding rotation. You would go from 80 to 100 to 120 to 150 to 180, and that way these scratches progressively get smaller and smaller and smaller and smaller until you're at your final size. Now I do need to keep the sandpaper moving. If I stop in one spot too long, I'll get burn marks, just like when we sand with regular sandpaper or on a regular piece of material. Now, I notice that it's easiest to get spending too much time in these cove cuts, and that's typically where I see my burn marks when I'm sanding. So let me show you what that might look like as you're sanding and you're staying in one spot too long. So we've created a little burn mark here in the center, and that's happened for a couple reasons. It's gotten too hot. We've actually stayed in one place too long on the sandpaper, have removed all the grit and got down to the paper. So that's likely what happened, is that just was friction there. It wasn't actually gritty and sanding, and so that's what caused the burn marks. So your entire material should be that blemish free from the tear outs. Okay, it should be nice and smooth to the touch, no rough spots on there. So if we turn this a little bit, this is kind of what we're indicating or looking for, is a nice smooth surface and all of your burn marks removed. Now we talked about this cross grain, and we can remove this cross grain by sanding with the grain. Now that the machine is turned off, if we take the last grit that we finished with, the finest grit, and we take and just sand by hand, slowly rotating the head of the machine to not create any flat spots, we can take care of a lot of that cross grain. All right, as we take a closer look here, this looks pretty good. All of the cross grain has been removed. If I turn this a little bit, I did not sand this side, and hopefully you can see this cross grain that we're talking about, the scratches that are against the grain. If we do not take care of these, when we go to put a finish on this project, these areas are going to pop out and almost magnify those defects that we didn't take care of. So that's the cross grain right in there that you see, those scratches. And if we turn this a little bit, I spent some time here sanding this section, and that cross grain is all gone. Now we haven't spent the amount of time that we should on all of this, but I'm going to show you how we would apply our friction polish here on the lathe. We're going to turn the lathe back on to full speed. We're going to take some wax, this happens to be beeswax, and we're going to hold it on there and it's going to melt in. Then what we're going to do is take a clean rag and come back over that section and heat that up, and it's going to melt into the pores of the wood. So let's take a look at that. So here's our project without finish, and with finish you can see it gives a much nicer look to the project. The finish also protects the wood, so if you touch it with dirty hands, you can easily clean it off. And it seals the wood, so things like moisture that may be a little bit damp don't actually penetrate into the wood. Now when you're doing this, you want to make sure you get all of your area, but also don't forget about your end grain or your end of your project down here. You want to make sure you sand that and finish that the best you can. So we've added the wax here, and you can see how those defects have kind of magnified. They're not fully got the finish down in there. They're a little bit more noticeable. Our cross grains are a darker color here. We can really kind of see them in person. I don't know if you can see them on the camera, but they are really nice and noticeable. So we do need to spend the time. Here's that section where there's no cross grain that I sanded. We really need to take the time to get all of that cleaned up before we start to put a finish on, because those defects are going to pop out if you do not take care of them. If you have any questions on this machine or any other machine in the shop, please talk to your instructor. We want to get these questions answered for you so you understand how to use the machine correctly and safely.